So here we are, slope, algebra 1, math 1, basic, but the concept of a slope, linear slope, is so foundational to calculus. It says find the slope of the line that passes between 2 points. So I see the 2 points. Understand slope is the change in y over the change in x. And then just be able to find it, right? So rise over run, what would the slope be? So in this case it goes up 3 and to the right 4. Here you can see it's a negative slope, so how many down and how many down? So it's negative 8 over 4 or negative 2. Just count down, count to the right. When you have a horizontal line, we think that slope is 0. That's a big concept too. If you have 2 points to find the slope, think of the change in y over the change in x. You can also think of y2 minus y1 and x2 over x1. So when I look at the y's, if they're small numbers like this, 3 to negative 7, I can see that it went down by 10. And negative 9 to negative 5 actually went up by 4. You could reduce it down to negative 5 over 2 if you felt like it. Here again, if I wanted to find the slope, negative 1 to negative 4, that went down by 3. 2 to negative 7 went down by 9. If you wanted to, you could write down positive a third. Again, the change in y over the change in x, y2 minus y1. So when I do that, I can see it went up by 8, and I can see this one went up by 12. And if you want to, you could reduce it down to 2/3. So for functions, the slope is constant between each pair of points. It doesn't change. For nonlinear functions, the slope changes between different pairs of points. Because of this, we find the average rate of change. And then the fun acronym for that is AROC. So the average rate of change of a function between 2 points is the slope of the line that passes through those 2 points. This is called the, and we're going to see the difference between a secant line and a tangent line. So a secant line means 2 points does it pass through. So a formula for the average rate of change, and we call that the AROC, is, and if we're using these points for this, you could think of, and this is the same as y2 minus y1. This is the same idea. That you subtract the y's on top and subtract the x's on the bottom if you have 2 points that you're finding in between. So, given that function, can you find the AROC between negative 2 and 1? So step 1 is to understand the points that we have there. So at negative 2, can you find what that point is on your graph? So at negative 2, if you count down, let's see, I'll make sure I didn't. Here we go. So from negative 2 to 1. So at negative 2, there it is. So at negative 2, I have to spot where that is on my graph. So at negative 2, what is the y coordinate? And then at positive 1, I go down to the graph, and then now I have my 2 points. So at 1, it went all the way down to negative 8. That, if you connect the 2 points together, is called the secant line. So secant means it goes through 2 points. The other word we're going to learn is tangent, and that's the slope of 1 point. But to find the AROC, simply put, we're going to do the slope between these 2 points. So if I look at the y and I look at the x's, I can tell that, first of all, the y's are going down by 9, and the x's went up by 3. So if I put that together, that's negative 3. So first, identify it on the graph. So 0. So 0, if I go down, what's that point? So that point is at 0, I see negative 7. The other's at 4. And when I go 1, 2, 3, 4, what's the point there? I see 1. Can you find the average rate of change using those 2 points if you connected them as a line, the slope? So look at the y's first. Negative 7 to positive 1, that clearly went up by 8. 0 to 4 went up by 4, so the average rate of change is 2. So on average, between 2 points, it increased by 2 every time, on average. right, turn the page. Can you find the AROC if it's not a graph but you're given an equation? So when I look at this in terms of it, I'm just going to use right away the formula y2 minus y1 and so on. So I'm going to go f at 2 subtract f at negative 1, and then on the bottom, same numbers without the f's, and subtract them. So there's the setup. So I do need to plug in 2 and get an answer. So if I plug in 2, I get the answer negative 6. If I plug negative 1 into here, and you do the work, I get negative 21. So I'm going to subtract a negative, and then the bottom I get 3. So when you subtract a negative, it's negative 6 plus 21. That's 15 over 3, so the average rate of change is 5. So you have to do a little bit of evaluating. It might even need a calculator if you're going to do something like that. So the setup is the most important part. So look at the two that were given. So it's f at negative 7 subtract f at negative 9. Order matters. And then the denominator would be negative 7 subtract negative 9. So we would need to plug negative 7 in to get an answer. You can use your calculator if you want, I think, in this situation. Plug in negative 9 and get an answer. You'd actually get 3. And then negative 7 plus 9 is 2. So if I put this all together, you can see the answer is negative 4. Number 11, again, can you set it up to find the AROC? So f at 7, subtract f at 4, and then the bottom's just 7, subtract 4. So I know this is 3. Plug in 7 and get an answer. That's 183. Plug in 4 and get an answer. That's actually negative 3. So when you subtract a negative, you're adding, and then it actually does go in evenly. And the answer is 62. The setup. So f at 5, subtract f at negative 2, and then 5 subtract negative 2. So if I plug in 5, I get the answer negative 567. If I plug in negative 2, I get the answer negative 21. And then when you subtract a negative, you're adding, so it's 7. So combine these together, subtract the negative again, you get negative 546 divided by 7, and that answer is negative 78. Again, f at 8, subtract, this is AROC. F at 8, subtract f at 2. 8 take away 2. So if I plug in 8, I get 4 divided by 8, I get a half. If I plug in 2, I get 2 take a negative 2, I get negative 1. And then the bottom I get 6. Good practice. 1/2 plus 1 is 1.5. 1.5 divided by 6 is like times the reciprocal. And so if I put it all together, times the reciprocal, that, right? Yeah. So this is really 3 over 2, so I'll write it that way, times it. And so this is 3 over 12. Last one. I'm not even going to, they say use your calculator at the end, it's fine. Setup. It's all about the setup. F at 7, subtract f at negative 1. And then denominator 7, subtract negative 1. So f at 7, if I plug it in, it's the square root of 12. Minus negative 1 is the square root of 4. And then 7 plus 1 is 8. And that's good enough. That is a 2, but it's fine. 15. A company's total cost in dollars in manufacturing X units is given by that equation. Find the average rate of change of the total cost for the first 200 units. So to do that, we first have to understand 2 points. So we're going the first 200 units, so 200 minus the 0. And then the bottom is just 200 minus 0. So plug 200 into there. You can use your calculator and calculate it. It's 11,200. Plug in 0. That's easy. It says 1,200. And then 200 on the bottom. That just simplifies to 50. So what's the average cost for the first 200 units? And the average cost per unit is $50. a ball is thrown straight up, so that its height t and feet is given by that equation, where t is in seconds. Find the AROC, the average rate change of the ball when it reaches its maximum height until when it reaches the ground. So one thing I don't know is the maximum height. This is a parabola. So we're going to use the formula negative b over 2a to find it. So b is 80, a is negative 16. So I have 80 over 32. If I use my calculator, it might be easier as a decimal, 2.5. So at 2.5, it reaches its maximum height. I needed to know that. It says the average rate of change of the height from when it reaches its maximum height until it reaches the ground. So now I need to know, when does it hit the ground? So this is important right here. To know when it hit the ground, I make it equal to 0. That means the height is 0. And then solve it. So if I solve it, I'm going to solve it by factoring. I'm going to factor out negative 16 t and be left with t minus 5. So the first one gives me the answer 0. That doesn't help. That's where it started, on the ground, I guess. And then the next one gives me the answer positive 5. So it hit the ground at positive 5, where it started, and then hit the ground there. So I guess when it was thrown up, it started on the ground and then thrown in the air, and then 5 seconds later it hit the ground. So we're finding the AROC from 2.5 to 5. So what's the setup? F at 5, subtract F at 2.5 divided by 5 minus 2.5. So F at 5, we know the height there is 0. At 2.5, if you plugged in 2.5 for t and you solved it, it would actually give you your maximum height, which is 100. And then the denominator is 2.5. So 100, negative 100 divided by 2.5, that gives you 40. And the answer is actually negative 40 feet per second because it's falling. So on average, how fast is it falling from its maximum height to the ground? So on average, every second it falls 40 feet. That's what it means. Let's see. Let's finish this. All right. Now let's practice what we just talked about. Given this function, find the average rate of change. So the AROC, what's the setup? It's slope. F at negative 2, subtract F at negative 5, and then negative 2, subtract negative 5. There it is. Look off the graph. So at negative 2, look off the graph to know what the value is right there. So if you look at negative 2 and go up, it's at 7. At negative 5, look at the graph. It's down here. It's a negative number. It's negative 2. And then the bottom, make sure you subtract a negative. So that's positive 3. So that's 9 divided by 3. So the answer is 3. Same graph. So what's the setup? F at 0, subtract F at negative 3 over 0, subtract negative 3. So at 0, you can see the answer is 3. At negative 3, you can see the answer is 6. And then the bottom is just positive 3 when you subtract the negative. So that's negative 3 over positive 3. So on average, it's losing negative 1 in terms of it. So it's decreasing from negative 3 to 0 on average. Negative 9 to 7. Setup. F at 7, subtract F at negative 9. And then 7, subtract negative 9. Off the graph, here's the bottom one. So 7, what's the answer? So for 7, the answer is 3. At negative 9, it's a negative answer, and it's negative 5. Here you're adding, so it's 16. So subtract the negative, you're adding again, so the answer is 1/2. Negative 2 to 0. So F at 0, subtract F at negative 2. So at 0, the answer is 1. At negative 2, the answer is negative 3. And then you're adding, so it's just 2. So you're adding here too, so 1 plus 3, and then you get your answer. Could you do that with an equation? So again, just the setup. So F at negative 5, subtract F at negative 8 over negative 5, subtract negative 8. When you plug negative 5 into here, you get negative 21. When you plug negative 8 into here, you get negative 3. The denominator adding, so it's 3, and then combine. So negative 21 plus 3 is negative 18 divided by 3, so you get the answer negative 6. Here, again, f at 6, subtract f at negative 9 over 6, subtract negative 9. So when I plug in 6, I get the answer 1. When I plug in negative 9, I get the answer 4. Here, you add, you get 15. So you get negative 3 over 15, or you could write that as negative 1/5. Again, anytime you could press pause and practice. The setup. Be careful of those two negatives. Plug in 5, and you get 5 over 8. Plug in negative 1, and you get negative 1/2. And then on the bottom you get 6. It's good practice. Get common denominators. So you're adding 1/2 is the same as 4 over 8, and then you times the reciprocal. So if I put it together, I get 9 over 8 times 1/6, which is 9 over 48. And you could reduce that down to 3 over 16. One more time. F at 14, subtract f at 8, and then 14 take away 8. So when you plug in 14, it's okay if you use your calculator, you get negative 55. You plug in 8, and you get negative 7, and there's a 6 in the denominator. Negative 55 plus 7 is negative 48, divided by 6 is negative 8. Done. Average rate of change, AROC. Keep practicing on the back. F at 5 minus f at 1, 5 take away 1. So when you plug in 5, what's the answer? You get 153. Plug in 1, you get the answer 1. And 4 in the bottom, so this is 152 divided by 4, so you get 38. We're going to do the same thing here. F at 10, subtract f at negative 1. Over 10, subtract negative 1. So when you plug in 10, you get a fraction, 25 over 3. You plug in negative 1, you actually get the answer 1. Here, it's 11 on the bottom. We can leave it. F at x.
Alyssa Hernandez, please report to the front office. Alyssa Hernandez, please report to the front office.
So the bell went, so people will be coming in, but that's okay. So plug in 2, and you get the answer negative 4. Plug in negative 2, and you get the answer 12. That's a 4 in the denominator. Reduce it down, you get negative 16 over 4, which equals negative 4. The cube root. So here, f at 7, subtract f at 0, over 7, take away 0. If you plug in 7, you get 28, take away 27. Cube root is 3. 0 gives you negative 1, which is negative 1, and then 7. So if you add that up, you actually get 4 over 7. F at 8, subtract f at negative 3. Over 8, subtract negative 3. Plug in 8 and simplify it, you get 5 over 4. Plug in negative 3 and simplify it, you get negative 7. In the bottom, you have 8 plus 3, which is 11. So you have 5 over 4 plus. Now, if I want to change 7 over 1, you'd multiply it by 4 top and bottom so that you could have common denominators. And then you'd multiply times the reciprocal to get your answer. So if you did that, you would get 33 over 44. And that's fine. You can divide by 11 if you want and get 3/4. One more like that. F at negative 5, subtract f at negative 9. The denominator, you have negative 5, subtract negative 9. Plug in negative 5 and you get negative 2. Plug in negative 9 and you get negative 326. The denominator simplifies to 4. You're adding there, so you actually get positive 324 divided by 4, and that's equal to 81. The actual calculations, I'm fine with you using a calculator. It's the setup that I'm looking at. A couple story problems, then we're done. The average low temperature by month in Nashville is represented here. where X is. Find the average rate, the AROC, from March to August, in terms of it, where X is the month. So we can assume that March is the third month. Come on in, it's okay, Esteban. You're now famous. And then August would be the 8th month. So I'm going to go F at 8, subtract F at 3, and then subtract the denominator. So when you plug in 8, you get the answer, and it's okay if you use your calculator, 64.1. If you plug in 3, use your calculator, you get an average temperature of 46.1, and then the denominator is 8, take away 3, which is 5. Use your calculator again, and you get the average rate of change there is 3.6 degrees per month. Number 16, the last question here we're doing together. So a rocket was launched into the air. Ladies, you can say hi to the video I'm doing right now. We have one more question we're doing on the video right now. Hi. Hi, Alma. So let's finish this so I can finish the video. A rocket was launched into the air from a podium 6 feet off the ground. The rocket path is represented by this equation, where h at t represents the height in feet and t is in time in seconds. Find the AROC, the average rate of change from the initial launch to the maximum height. So the initial launch is when it is 0, but what we don't know is how long it takes to get to the maximum height. So we're going to use the formula negative b over 2a to find the maximum height. So in this equation we have 120 and we have negative 16. When I reduce it down and use my calculator, I get 3.75, and then take that answer, 3.75, and plug it in for t, and then calculate it all the way through to get the answer. So for that, you get 231 as being your maximum height. So our AROC then is going to be F at 3.75, subtract F at 0, and then in the denominator, 3.75, take away 0. So we use 231, that's the maximum height. When I plug in 0, it started at a height of 6. And then the denominator is 3.75. Use your calculator to calculate it all the way through, and you actually get 60 feet per second. So on average, the rocket was going up at 60 feet per second. So good job working on average rate of change and practicing with me.